Honors Geometry, Unit 3, Day 3. Okay, let's start with one of the easiest things you probably will ever do in mathematics, and that is looking at congruent parts of congruent triangles. Okay? Corresponding parts of congruent triangles are always congruent, and we'll talk about the congruent statements a little later on. Okay, but right now you're just looking at the markings. Look at the markings. If we are filling in these answers, it says angle A is congruent to angle blank. Well, look at angle A. Angle A has two marks. It has two angle slashes. Angle Z has two angle slashes. So you would simply write angle Z. Told you this was easy. Angle B has one congruent mark. Angle Y has one congruent mark. Angle C is congruent to, well, angle C has three congruent marks, and X has three congruent marks. Right? Segment AB. AB has three congruent slashes, and it happens to join the angles that have a 2 and a 1. So if you look on the other side, you have three angle slashes, and it joins the 2 and the 1. So that would be YX, or excuse me, YZ. Now, if you said ZY, that's fine. Okay, line segments can be written either way because you just have two endpoints. Okay, segment AC. AC has one congruent slash on it, and also AC joins angle A, which has two marks, and C, which has three marks. So if we look here, we got the one congruent slash, and it happens to join the 2 mark and the 3 mark. Okay, so that gives us XZ or ZX. Okay, and then finally, we look at BC. BC has two markings. It joins the 3 angle mark and the 1 angle mark. Okay, so if you look over here, BC, there's 2 angle markings, and it joins the 3 angle mark and the 1 angle mark. That's going to be XY or YX. Okay, so this part right here, the congruent statement, you have to have corresponding parts being congruent. So C, A, B, in that order. C has 3 angle markings, okay, and we know that C corresponds to X, so we're going to use X first. A had 2 angle markings, and it corresponded to Z, as we already knew, so we're going to use Z second. And then B, well, B corresponds to Y, so we're going to use Y third. The order matters in congruence statements. Okay, so when you say triangle, okay, well, let's say triangle congruent statements. Triangle CAB is congruent to, if you had said triangle XYZ, it would be incorrect because the first letter corresponds to the first letter. Okay, those angles have to be congruent. The second letter have to be congruent angles. Third letter have to be congruent angles. The first and the third, that segment has to be congruent to the first and the third. So CB and XY would have to be congruent, okay, which they are. If you change the order, you will then lose the truthfulness of your congruent statement, and therefore you can't use it. Okay, so you need to remember that. The order matters, and if I just give you this statement here, Right? If I give you that without even drawing it, you can immediately tell me that angle C is going to be congruent to angle V, for example. You can also tell me that segment BC is going to be congruent to segment TV, because the order matters. Corresponding parts of congruent triangles are congruent. We'll be getting into that in day 4 with CPCTC proofs. You don't have to remember that yet. You will, but not yet. Okay, so what are all the triangle congruence theorems? Congruence theorems just mean that, okay, right here, we know that the triangles are congruent because we found all 3 angle measures, or all 3 angles were congruent to the other 3, and all 3 sides were congruent to the other 3. So that's 6 parts. We found 3 angles and 3 sides are congruent to the other triangle's 6 parts. I don't want to find that many parts. So there are some theorems, okay, or postulates here. You only need to find 3 things to prove that 2 triangles are congruent. Okay? The first scenario is called the side-side-side. You can abbreviate that with SSS, side-side-side postulate. So if, let's say, this side is congruent to this side, and this side is congruent to this side, and this side is congruent to this side, then we could say that those 2 triangles are congruent by the SSS triangle congruence postulate. Okay? Angle side angle. Please notice that the S is between the 2 A's. It is called an included side. Means if you look at the first angle and the second angle, there's one side that's part of both of those angles. It's included between them. So that means that's ASA. So for example, if this angle is congruent to this angle, and this angle is congruent to this angle. Okay, so which side is between the 2 angles? Well, this side. This side right here is part of both of those angles I just marked. Just like this side is part of those 2 angles that I just marked. All right, so if I have these markings, okay, then I can state that these 2 triangles are congruent by the angle side angle triangle congruence postulate. Okay, let's drop down here to the side angle side, SAS postulate. Okay? We'll be dealing with that one today in our proofs. So again, you have 2 S's and then the A is included between them. Included angle. Okay, so for example, if I have this side is congruent to this side, and this side is congruent to this side, then for SAS to be used, okay, look at this side and this side. Well, the angle that's included is the angle that's created by those 2 sides. It would have to be this angle right here. Okay, so by the side angle side congruence postulate, I can say that those 2 triangles are going to be congruent. Okay, angle angle side, notice the S is not between the A's. So this S is a non-included side. So if I said that, let's go, this angle is congruent to this angle, and this angle is congruent to this angle. All right, the included side would be this guy. That would be ASA. But we're not looking for ASA right now. We want angle angle side. So I want one of the other 2 sides. So I could have this. Okay, so that would be this guy. Okay. So angle angle side, angle angle side. So by the AAS congruence postulate, I can state that those 2 triangles are congruent. Right? Now, just because I want you to know that there are 5 congruence postulates that we'll be using. I'll include hypotenuse leg, even though hypotenuse leg we're going to get into in the day 4 notes. We're not going to include it in the proofs today, or at least not for these notes, right? But hypotenuse leg, okay? Because we said here, we got 1, 2, 3 things for every triangle. 1, 2, 3 things, okay? So here we got 3 sides. Here we got 2 angles and a side. Here we got 2 sides and an angle, okay? You say, well, HL, that's only 2 things. But what type of a triangle has a hypotenuse? There's only one type, and that type is a right triangle. So just by the fact that we have HL, we have to unlock the opportunity to use HL by saying we got right triangles. Then the hypotenuse is congruent to the other hypotenuse, and then one of the legs is congruent to one of the legs. Okay, so hypotenuse, leg, it's a right triangle. Right? I'm not going to go further into that because we're not going to see that again today. All right, identifying and naming congruent triangles. So let's look at this little baby right here. All right, look at the markings. Okay, use their markings to see if they're congruent. They have to follow one of these 5 congruence postulates in order to be legitimately congruent. All right, so I'm going to say we have an angle. We have another angle. That's the side that's included between the angles. Okay? So according to this triangle, I've got ASA markings. Let's look at the other triangle. We've got an angle. We got another angle. And we got the side in between. So this again is ASA. So this side is part of those 2 angles, therefore it's angle side angle. So by the angle side angle congruence postulate, I can say that triangle ABC is congruent to triangle. Now here's the part, got to watch. The order matters. So A is the first letter. A has 1 angle marking on it. So that means I've got to use the 1 angle marking F. What about B? B is the second letter. B has 2 angle markings, so does D in the other triangle. And that tells me that C, which is the third one, is going to correspond to E. And if you look, they happen to have no markings on them. But you can see that C is opposite this 1 congruent slash, just like E is opposite this 1 congruent slash. So they do correspond to each other. So you would have to use FDE in that order. Okay, don't switch them up. Okay, if you put EDF, wrong. Okay, all right, let's look at this next guy. All right, so here I've got a side, and I've got an angle, and I've got a side. Okay, so I got 2 sides, and I got the angle included between them. Sweet. Okay, that's an SAS. But let's look at the second triangle. I have a side, I have an angle, and I have another side. Okay, so I have a side, an angle, and another side. But is that SAS? Well, if I look at the 2 sides, that's not the angle that's included between them. So it's not SAS on the second triangle. It's not SAS. So we cannot use that congruence postulate, okay, because SSA is not a congruence postulate. Also, you know, if this is SAS, this one's got to be SAS. Didn't work out. Okay? Might they be congruent? They might, but not necessarily. Not by the markings that you have there. Okay? All right. So now we are completing proofs involving congruent triangles, and we're going to use either angle side angle or angle angle side. Right? We're just going to fill in the blanks for these. Okay? So let's take a look up here. I want you to notice some things. Notice that they have some given information. They're always going to use the givens. And then they have what they want to prove. And what they want to prove is always going to be the last statement, because that's their conclusion. Okay, they want to create a nice deductive argument based on given information and theorems and proven statements in order to prove their point. So once they prove their point, we're done. Okay, so let's see what they did. First, they said PRQ is a right angle. How do we know that? Well, because it was a given information statement. Then they said PRS is a right angle. And again, we know that because it was given information, okay? So now finally, they say statement number 3, angle PRQ is congruent to angle PRS, okay? Is that also given? No, that's not what that says, okay? So we have to look at the statements that were made. Okay, PRQ is a right angle. All right, so I'm going to put a right angle mark there. PRS is a right angle. We'll put a right angle mark there. Okay, PRQ is congruent to PRS. Now, if you look at the drop-down menu on Alex, okay, it states, one of them states that if I have right angles, then they are all congruent. So from the drop-down menu, it will say all right angles are congruent. And that should make sense because congruent angles simply have the same measure. Well, all right angles have 90-degree measures. So all right angles are congruent. Good enough. All right. Now in statement 4, it says the reason is given. Well, we've already used this one and this one, so I guess we got to be using that one. Angle PQR is congruent to angle PSR. And the reason that we know that is it's given information. So let's write that down, right? PQR is this angle. PSR is this angle. Okay, so in the triangle, in this upper triangle versus this lower triangle, right now, notice we have an angle and another angle. Angle and another angle. Okay, just notice that. You don't have to write that if you don't want to. I like to write those. And then finally, it talks about the reflexive property. The reflexive property is so easy that it's a reflex, okay? Anything is equal to or congruent to itself. So 5 equals 5. 10 equals 10. Blue chair equals blue chair, okay? Jason equals Jason, right? Anything is congruent to, which means the same size, same shape, itself, right? So using the reflexive property, you're saying something is congruent to itself. So if they're saying segment PR is congruent to itself, segment PR. You say, why would they say that? Well, this is why. Segment PR is part of both triangles. So I'm gonna just put the marking on it twice there. So look at the red markings. Now I'm going to erase my little A's here. Okay. So look at the red markings here. We got an angle, we got an angle, and we have a non-included side. Okay. Look at the gray markings up here. We got an angle, we got an angle, and we got a non-included side. Okay. So PR is part of both of those triangles. That's why it was important to use the reflexive property to say that PR is congruent to PR. Okay. So we have an angle, we have an angle, and we have a non-included side. That's a reason that two triangles are congruent. That's one of our 5 congruence postulates for triangles. So they say the triangles are congruent, and the reason is the angle-side congruence postulate. Pretty nice. Filling in the blanks. You do need to know the reflexive property. Okay. So now they're going to give you some very basic proofs, but these are going to be ones that you have to write the statements and the reasons of. Now, because of that, I uploaded a very, I think, if I do say so myself, a very helpful, very helpful sheet that's called Helping You with Proofs Dealing with Congruent Triangles, right? And I want you to refer to it when you do your first few proofs, and then after you've done a few, you should be able to do these second nature, right? But I try to point out some very obvious similarities with all of the proofs that you have to create, because we're going to be doing proofs that all deal with congruent triangles, right? There are a lot of similarities with them. So, you know, take this sheet and use it. All right. Well, now, before I go away from this sheet here, give you some tips, okay? Don't write congruent until you actually have written the marks up in your picture, right? You should be coming up with a game plan and then putting marks in as you go. But don't write anything in for marks until you hit that congruent symbol, okay? So back here with this proof, right, I would not make this mark until I had something saying that that angle is congruent to angle PQR. Okay, I would not make those congruent marks until I had the symbol congruent in a statement. Okay, I would not make those congruent slashes until I had written that PR is congruent to PR by the reflexive property. Okay, so until you have written the statement, do not put the marks. Okay, all right. So I'm going to look at this and I'm going to see what kind of game plan I have. Okay. Here's your game plan. I'm going to just write game plan here. My game plan is going to say which type of triangle congruence postulate I'm going to use to prove what I want to prove. So triangle DEF is congruent to triangle GHF. That's what I'm going to prove. So this triangle and this triangle are congruent. All right. So if you look at this here, the first thing that I'm going to tell you to do is to take the given statements. Okay. So I'm going to write down some markings based on these, but I don't want you to write them down yet. Okay. Don't write this down. I'm doing my game plan. Okay. If you want to write these very lightly in pencil and then erase them in a second, that's fine. But otherwise, don't write it. So this is my game plan because I'm going to erase it as soon as I write it. EF and HF, I'm going to have markings on them eventually. And then DF and HF, no, excuse me, GF, I'm going to have markings on them. So from my givens, okay, from my given statements, I'm going to be able to get those markings, okay? So it says, try to get congruent marks out of every sentence in the given, okay? Out of every sentence in the given, okay? We'll talk about this when we get to, you know, one of our further questions here, okay? After the givens, look at the picture, look at the diagram. There are two things in your pictures that will allow you to make congruent marks just because of the pictures. One of them we've already seen in the previous example. If you look right here, this segment is in both triangles. So we can say that BC is congruent to itself. And the reason is Well, that's the reflexive property. So if I see this in a picture, I can say, I'm going to be able to make that marking. I know I'm going to be able to make that marking. The second thing that you could, okay, so that was the first one, if they share a side. The second thing that you could make markings on is something we did in Unit 1. If I have two segments that intersect, you know that vertical angles are congruent, okay? I could write angle ACB is congruent to angle ECD. Why? Because they're vertical angles. Vertical angle property says that all vertical angles are congruent. So when you look at the picture, if you see a shared side, or if you see vertical angles, you can go ahead and say, I can make marks there. Okay, so here, what do I see? I don't see a shared side between that triangle and that triangle, okay? They don't share a complete side, but I do see, I see vertical angles. I see vertical angles. Okay, so from that, I'm looking at two sides and an angle that's included between them. So my game plan is going to be to use side, angle, side. Okay, now I'm going to erase all these things because I haven't written anything in my statements over here. So I have not earned the right to make my markings, but I do know what my game plan is. I know that my last statement is going to be that these are congruent, and I know that I'm going to want them to be congruent by SAS. All right, so back very briefly to my other sheet. First thing I want to do is to take care of my givens. So let's do that. All right, let's use, let's go with gray. My first statement, I'm going to take my first given. Segment EF is congruent to segment HF. And my reason, it's quite nice. It's given. All right, now I just wrote congruent. So I can make congruent marks on my diagram. So I know EF is congruent to HF. Okay, good. Second statement. There's another line of givens, so I'm going to keep writing givens. DF is congruent to GF. And again, that's given, so my reason is given. I just wrote congruent for two segments, so I have the right now to come over. I'm going to do a double mark because I've already used the one marks, so I'm going to use the double mark on DF and GF. Okay, so is that all of the given information? And have I gotten congruent stuff out of this line and this line? Yes, I have. So the second thing I'm going to do is I'm going to look at my picture. And we already said that in my picture, I see vertical angles. I see vertical angles. So what is the name of that angle right there? Well, you can't call, this is a very common mistake. You can't call it angle F. Okay, why can't you call it angle F? Because I see a bunch of angle Fs. Okay, so you have to use three letters. Okay, 3 points. You're going to start with a point on one side, and then the vertex, and then a point on the other side. So let's go EFD. I'm going to call this angle EFD. Angle EFD is congruent to its vertical angle, this guy here, and we can call that HFG. Angle HFG. Okay. And the reason that we can say that those two angles are congruent, vertical angles. You can call it the vertical angles property, or you can say vertical angles are congruent, whatever you want. I just wrote congruent. I can now make my markings. Cha-ching. Okay, so I've done every given. I've gotten congruence out of each line. I've done the picture, and I got something congruent out of the picture. Now I'm going to look at, Let's see if it's stated here. Okay. Number 3, look at your marks and see if you have one of those congruent statements. Do we have one? If we do, then we're going to say that the two triangles are congruent. Okay, so let's go black on this one. We have a side, an angle, a side. Yep, we have a side, an angle, a side. SAS, SAS, in order, perfectly done. So I can immediately say that these two triangles are congruent. Triangle, now does the order matter? Well, yes, the order matters. And since we already know what order they want us to put it in, I'm going to start with DEF. DEF. The order of the first one usually doesn't matter too much, but they kind of gave it to us. Now the order of the second one, we're going to base it on the order of the first one. So they started with D. Okay, D, take a look at D. D is this angle that is opposite, it's opposite of this side that has one marking on it. So opposite the side that has one marking on it is angle G. So luckily, angle G corresponds to angle D. Angle E, this guy right here, E is opposite the 2 mark. So opposite the 2 mark is H, which luckily they told us anyway. And then third angle is F. Okay. So because of the side angle side congruence postulate, I can say that those two triangles are congruent. Okay. Now the last thing that we want to do is you look at what they said we're going to prove. Did you prove it? If the answer is yes, you're done. And you just did your first 2-column proof that had more than 2 steps in it. Okay, you didn't fill in the blank, you created it, and you finished it. All right, you can pause me now and try this next one on your own, which would be great, and then just kind of fast forward to the end and see if we got the same thing. Or if you want to just stick and we will do this together, that's what we're going to do. Okay, so pause or unpause. Okay, so I'm looking at this triangle DEF and FGD. So that would be DEF is this triangle and FGD is this triangle. Okay, so we're looking at this guy and this guy. Okay, so what is my game plan? All right, my game plan. Let's look at what they gave us, the givens. Okay, now again, don't write this down, especially if you have pen. You can just kind of lightly put it down if you want. Okay, DE, they gave us is congruent to FG. They've also given us EF, put a double mark, and GD. Okay, that's everything I can get from both lines of the given. Now, my job is to look at, what's number 2? The picture. Okay, does this picture have vertical angles like the first one? No, only this hourglass looking thing will have vertical angles in it. Does this have a shared side? Does this side happen to be part of both of these triangles? Well, it's DF, and check it out, DF, DF. Yeah, it is, it's a part of both triangles. So that means I'm going to need to remember that side. Well, do I have enough markings? Side, 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 side. That reminds me of, yes, we can use SSS as a congruence postulate. So that means my game plan is going to be to use the side, side, side congruence postulate. Okay, now I go back and I erase all that stuff because remember, we're not going to write any markings down permanently until we have written the statement that says congruent. Okay, that's important. So let's go with orange. Yeah. So first, we're going to take care of the givens. Then we will do the picture. Then we will figure out if we got enough markings to say that our triangles are congruent. Okay, that's what we're going to do. So first, the givens. We know that DE is congruent to FG. And the reason is given information. So DE, 1 mark, FG, 1 mark. Good so far. Statement 2, segment EF is congruent to segment GD. How do I know that's true? It's given information. It's given. So I wrote congruent. I can put a congruent double slash on EF and a double slash on GD. Okay, that's it for the givens. Now I look at my picture. I see a shared side. It's DF. So DF is congruent to itself. And if you say it's congruent to itself, then you just use the reflexive property. The reflexive property. Okay, I wrote congruent. I'm going to put 3 markings on this guy. Okay. I used the givens. I used the diagram. Now I'm going to look to see if I can say that my triangles are congruent. So let's see. We got S, 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 S. You got it. So I know that by the side, side, side congruence postulate that the triangles are congruent. Now, it's nice to go through and make sure that your segments match up. So DE is the first 2 letters of that triangle. DE has 1 angle mark on it. 1 side congruent slash. Okay. For FGD, the first 2 letters are FG. FG has 1 congruent mark on it. So they match up. How about EF and GD? Yeah, EF has 2, GD has 2. And then DF and FD, it's the same segment. We already know that they're congruent. There's 3 markings on that. So I'm just going to copy down that. Triangle DEF is congruent to triangle FGD. Why? Side, side, side congruence postulate. Awesome. Okay. Let's go to some proofs where we just have one more thing to do. And that is we have to look at the givens, and the givens might say congruent or they might not. That's why I said, okay, try to get congruent marks out of every sentence. Every sentence. And now I gave you an example here. Here's an example. Given B is the midpoint. It didn't say anything about congruent, but because you know what a midpoint is. If it says B is the midpoint of AC, if I say B is the midpoint of AC, I know that and that are congruent. How do I know? Because that's what a midpoint is. Okay, so you would be able to write segment AB is congruent to segment BC if that were a given. And the reason is, well, that's the definition of midpoint. Right? So there's going to be something in that given that you're going to use the definition of. Okay, midpoint. Okay, if it says bisect, angle bisector, segment bisector, okay, it'll give you something that you can use to get congruent stuff. All right, so I want to know what my game plan is. All right, let's look at this given. Okay, EF and GF, EF and GF, okay? DF bisects or cuts in half angle EFG. So EFG is this angle here, and DF cuts it in half. So I know that this angle and this angle are going to be congruent. Okay? Because that's what angle bisector does. It cuts an angle into two equal halves, bisects it. Okay, that's it for the givens. Then if I look at the picture, there's a shared side right down the center. So what have I got? I've got an angle right here. I got a side here. I got a side here. So if I look just in this triangle, I've got side, angle, side. Two sides with the angle included between them. So I know that my game plan is going to be side, angle, side congruent. That's what I want to use to prove that I have these two triangles congruent to one another. Okay. Great. Here we go. Okay, first, the givens. Let's take this, put it right here. Segment EF is congruent to segment GF. Reason, given. Okay, because I wrote the congruent marks, the congruent symbol, I can make my congruent marks. EF and GF are congruent. Sweet. There's more givens. DF bisects angle EFG. Okay, that's given. Now, does that say the word or the symbol congruent? No. I'm not going to make my mark up there yet. But remember, in the givens, okay, we are going to try to get marks from every sentence, okay? We may need to do something like write another sentence after it, okay? So what does DF bisects EFG allow us to say? Well, we already said it. DF bisects this angle. So that means I know that this angle has got to be congruent to that angle. Okay, what are those angles named? This guy right here, we can call it GFD. Okay, don't call it angle F. Okay, angle GFD is congruent to angle, and we need this guy. We can call this guy angle EFD. EFD. Okay, now how do I know that those two angles are congruent? Now you have to go back to what you have written. And you say, oh, it's because of this word. Something about bisects. Okay, and under your Alex drop-down statement, there will be definition of segment bisector, definition of angle bisector. Well, these are angles. This bisects an angle. So it's an angle bisector. So because of the definition of what an angle bisector is, okay, because I know what an angle bisector is, I was able to say those two angles are congruent. And now that I have used the congruent symbol, I can make congruent marks. All right. So we have used both lines of the given to allow us to have congruent written down once per line. 2 lines, 2 congruents. Now we look at the picture. Look at your diagram. And once again, we see this guy going right down in the middle. He is a shared side. So segment DF is congruent to segment DF. And we know that those are congruent to each other because it's the same side. That is so easy. It's a reflex. It's the reflexive property. Okay. So because I wrote congruent, I can put the markings. Okay. So givens, done. Picture, done. Look at your markings. Do we have enough markings to say we got congruent triangles? Yes, we do. S, A, and S. The game plan came true. We got it. All right. So because of the SAS congruence postulate, I can say that triangle, okay, now they gave us the triangles in my proof, so I know I've got to use it here. So triangle DEF is congruent to triangle DGF. Okay. Now, last thing that Alex asked, and I kind of like it, right? Because you used SAS, which lines allowed you to write those congruent marks? Well, remember, I said you only use the congruent marks when you have written congruent in the statement. So that right there was written, that's the first side, that was in 1. And then this congruent was written in statement 3, that's an angle. And then the last congruent is the last side, and that was in line 4. So SAS was in lines 1 and 3 and 4. Okay, hopefully that's nice and clear. Let's do one more. Again, you might want to pause, try this one, and then unpause in a second, okay? But I'm going to just run down through it, all right? You may just think that it's so easy, you just want to go to the end right now. Go for it, if you're comfy with it. But I'm telling you, proofs, you'll get it with practice. I guarantee you'll get this with practice. You do a few of these, it's going to be like second nature to you. All right, so take my advice, figure out the game plan. Okay, here we go, my game plan. So I'm going to take the givens. DC is congruent to AC. DA bisects segment EB. So what got cut in half? Well, DA cut in half EB. So EB got cut in half. So because of that statement, I know that EB got chopped into 2 equal halves, that half and that half. Okay? Givens are done. Now I look at my picture. In the picture, do I see a shared side? Well, in the past, some people have tried to say, yeah, there's a shared side, but that whole side, AD is not in this triangle. Not all of it, maybe a piece of it, but not all of it. And AD is also not in this triangle. Okay, maybe a piece of it, but not all of it. You need the whole side if you're going to have it with the reflexive property. Well, what do you have here? Look at this. You got vertical angles. Okay, so I got sides and I got the angles. That angle is included between the 2 sides. So we have SAS as our game plan. Okay, that's what we're going to try to get. SAS to prove that we have 2 congruent triangles. Okay, so let's go right for it now. All right, first given, DC is congruent to AC. Reason is it's given, so DC and AC congruent. Nice. Okay, next one. DA bisects EB. It's given. Does not say congruent. I'm not going to make a mark until I write congruent. So, because I said this bisects this, something must be congruent. Yeah, EB got cut in half. It got cut into these 2 halves, right? So I can say that EC, segment EC is congruent to segment BC. This one and this one. Got to be congruent. Why are they congruent? Well, look right up here. A segment got bisected. So this is the definition of a segment bisector. That'll be on the drop down in your Alex, okay? It wasn't an angle that got cut in half. We got 2 sides now, okay? EC and BC are 2 sides that are congruent to each other. Okay, Both of the given lines are in. I've got congruence out of each of them. Next thing we're going to look at is the picture. And there's my vertical angles. Okay, so ACB. Okay, so angle ACB is congruent to this guy, angle ECD, angle ECD. How do I know it? They're vertical angles. Okay. So you can say the vertical angles property, or you can say vertical angles are congruent. I think it says vertical angles property in Alex, but vertical angles are congruent is the property. Okay, so I've done the givens and the picture. Next, I'm going to look at my markings. Do I have enough markings to say that I have two congruent triangles? Yes, I do. SAS. Two sides and the included angles for both triangles. So this is going to be because of the SAS congruence postulate, right? And I know the order because that happens to be exactly what they want me to prove. Triangle ECD is congruent to triangle BCA. Okay, so it's because of SAS. So there's the first side. That was in 1. Here's a second side. That was in line 3. And then here's the angle, and that was in line 4. Okay. So because of lines 1, 3, and 4, we got S and A and S. Okay, that is pretty sweet. So again, use this this lovely sheet that I gave you. There's more on the sheet than you need for this day's notes. Okay, only go up through where we went through here. Okay, up through here. If you go past it, then you're going to start getting into hypotenuse leg and CPCTC, which you will have in day 4 notes. But for day 3 notes, we're done. See ya.